Welcome back, you guys. We're going to talk 6.2. This is just a little introduction to the unit circle approach to trigonometry. And so what we're going to do is we're going to start with the unit circle. So what is the unit circle? The unit circle is a circle centered at 0, 0 with a radius of 1. Let's see if I can't draw an okay circle. Okay, so it has a radius of 1 unit, right? So that's the 0.10 on that. Actually, I don't want to dot that. Now what we're going to do in trig is we're going to take a real number line. So if you can imagine just a plain old real number line, and I'm going to line up 0 right at this point 1, 0. So if you can vertically like this for a minute, okay? So that 0 projects onto 1, 0. Okay, so this is the real number line. These are the positive numbers up here. These are the negative numbers down here. What we're going to do is we're taking the real number line, we're projecting it to a point on the unit circle. So for any unique t real number on the real number line, there's a unique point x, y. Okay, so for example, like let me go out t distance, and if you can imagine, now I'm going to wrap it around so it locates, this t locates to a point on the circle xy, if you can imagine. Okay, so if I'm wrapping it around, notice that distance t is my arc length. So this is arc, that's an arc length, that's a t distance around the circle. Okay, and if you remember from last time, we have the arc length. Remember, this was our arc length of the circle, was the radius times the central angle, right? This is our central angle right there, that arc length. Well, we're calling this distance t. Our radius is 1. So in all actuality, our arc length on the unit circle is equivalent to the theta rotation. So this is t as well, because our radius is 1. Okay, and this is the unit circle approach, it's called, to trigonometry. I'm just trying to give you a little bit of background for this. So then we define the 6 trig functions are defined from here. So the sine of t, the sine of t is the y value. It's also the same as sine of theta, right? Because remember, t is equal to theta on the unit circle. So the sine of t is the y value. The cosine of t is the x value. The tangent of t, tangent is defined as sine over cosine. And since the sine is the y and the cosine is the x, the tangent of t ends up just being the y value over the x value. And then we have their reciprocals, the cosecant. So the cosecant of t, and maybe if you remember back from your right triangle trig, the cosecant is 1 over the sine. So since the sine is y, the cosecant's 1 over y. So sine goes with cosecant, s goes with c. Cosine, its reciprocal is a secant. So since the secant is 1 over cosine and the cosine's x, so this will be 1 over x. The cotangent of t is 1 over the tangent. So it flips the tangent over. In other words, instead of sine over cosine, it's cosine over sine. Cosine's x, sine is y. Okay? And so that brings us to our notes here. We'll get started. All right, so there's our sine is the y value, cosine's the x value, tangent's the sine over the cosine. Cosecant's the reciprocal of the sine, so that's 1 over y. Secant's 1 over cosine. Cotangents flips that tangent around, so that's x over y. All right, if you want to fill those in. So let's do a problem now. Suppose a point on the unit circle. Here's our point, right? So in other words, we've we've wrapped around t amount, which is a rotation of t, in other words, t or theta, right? Because they're the same on the unit circle at least, and it gives us this point. So here's our x, here's our y. So find all 6 trig values. So not too bad. You just say, well, the sine of t in this case, which is the sine of theta, is the y value. The cosine is the x value, -5/13. The tangent is the sine over the cosine. So in this case, the sine is -12/13, and the cosine is -5/13. And notice I gotta keep change flip. I gotta simplify that. I'm dividing by a fraction, right? So I multiply by the reciprocal to clean that up. So notice my 13s cancel. So I got -12 over -5, so 12/5. Negative over negative is positive there. The reciprocal of the sine is the cosecant. So the cosecant of t, which should be 1 over -12/13. So it'll just flip that over. So -13/12. The reciprocal of the cosine is the secant. So 1 over the cosine. So -13/5. And finally, the reciprocal of the tangent, the cotangent. So it'll flip, instead of 12/5, that'll end up being 5/12. All right, let's make sure we can punch a few in. Let's go ahead and find a calculator approximation of cosine 14 degrees. So if you do that, go ahead and jump into decimals.com. Let me pull that up. Decimals. So here's decimals.com. Go into the scientific calculator that we can use. Now notice right here, see how I'm in degrees right here? Make sure you're in degrees. If I change that, now I'm in radians. I want to be in degrees because I'm punching in cosine. And you can search for it in functions. I'm doing cosine. Notice I have sine, cosine, and tangent is what I have here on this basic. So we're doing cosine 14. It knows it's in degrees. Enter. 0.97. Let me write that down. Thing here. So cosine 14 degrees. Make sure you can punch that in on decimals. Or approximately, let's say we rounded it to 2 decimal places. All right, I look to the right of the 7, and since it's a 0, right, that's got to be 5 or more to bump it up. It's not. It's less than 5, so we just leave it 0.97. All right, let's do that next one there. How about sine of pi8? Now notice, now I should be in radians, right? Notice there's no degree. Like this one had degrees on it, right? I saw that degree. That was the giveaway. This one does not. It's just a real number, pi8. So sine of pi8, we're going to punch that in. Make sure you're in radians when you go back. Pull up decimals. Let's punch that one in. Switch it to radians. Notice that changes that answer, so that's not what we're doing. This one we're doing sine pi for pi, or you can just click on the pi, divided by, I hit the slash button. Oops, divided by 8. Arrow to the right, end it. There you go, 0.3826. Let me write that down. So approximately 0.38. Now cotangent, notice I didn't have a cotangent function on there, but cotangent is the reciprocal of tangent. Tangent. So cotangent of 34 degrees is the same as 1 divided by the tangent of 34 degrees. And so that's how we're going to punch that in. Make sure you can do that on a calculator as well. Let's punch that in. Make sure I'm back in degrees. 1 divided by a tangent of 34, and I get 1.48, 256, and so on. Looks like I can leave it right there, 1.48. All right, let's keep going here. Let's talk about the 45, 45, 90. I actually like to do the classic 45, 45, 90. Most of the time, oftentimes you'll see it as opposite the smallest size. So opposite the 45 here is 1. Opposite the other one is 1, and then the hypotenuse would have to be square root of 2, right? Because 1 squared plus 1 squared equals c squared. So c would have to be that root 2. And so if you notice, what would the sine of 45 degrees be? Well, if you remember from right triangle trig, I kind of don't have room here. Let me go to the side here. From right triangle trig, do you guys remember SOHCAHTOA? So in other words, the sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. And then, of course, cosecant would just flip that. Right? This is for right triangle trig. So hypotenuse over opposite. Secant would flip the cosine around. So hypotenuse over adjacent. Cotangent would flip the tangent around. So adjacent over opposite. You remember that? I actually learned it a different way. I learned it that the sine, let me just, actually I'll just highlight it here. Oh heck, another hour of algebra. That's how I learned sine, cosine, tangent. Oh heck, I'm trying to be rated G here. Another hour of algebra. So I don't know how you guys learned it, but SOHCAHTOA seems to be the classic way that people remember that. But let's go ahead and do that now. So the sine of 45 degrees, if I look at the 45 degrees, the opposite side of it, so here's our reference angle. There's the 45. Its opposite side would be right here. The adjacent side is the leg right next to it. And of course the hypotenuse is opposite the 90 degrees. So sine of 45 degrees would be 1 over square root of 2. But then you got to rationalize the square root of 2. We can't have a square root on the bottom. So sine of 45 degrees is square root of 2 over square root of 2 times square root of 2 square root of 4, which is 2. Right? So sine of 45 is root 2 over 2. The cosine of 45, now I'm going to go adjacent over hypotenuse. So adjacent over hypotenuse. Well, it's also 1 over root 2. And I also have to rationalize that. So the cosine of 45 is also root 2 over 2. And the tangent of 45, now I'm going opposite over adjacent. So 1 over 1. Or you can take the sine over the cosine. Since they're the same thing, it just ends up being 1. Right? Root 2 over 2 over root 2 over 2. And the cosecant of 45, so that would be hypotenuse. So now hypotenuse over opposite. So square root of 2 over 1. Secant of 45, flip over the cosine and then rationalize it, which would be the adjacent, hypotenuse over the adjacent, root 2 over 1. And finally, cotangent of 45, adjacent over opposite. Okay. So we've got all these now. Tangent, there's our tangent, 45. There's all 6 of them for a 45 degree angle. Now let's talk about the 30, 60, 90. And you can kind of see how these right triangle trig kind of fits into our unit circle here. Again, I like to use the classic 30, 60, 90 instead of cutting it in half. So I go 30, 60, 90. Opposite the 30 is 1. Hypotenuse is 2. Opposite the square 60 degrees is square root of 3. Okay, that's the one I like to use. I'll talk about similar triangles and those other ones in just a sec. But let's go ahead and do sine of 30 degrees. So if I'm looking at 30 degrees, so here's our reference angle. the opposite side would be right here. The adjacent side is next to it. And the hypotenuse would be right there. So the sine of 30 degrees, remember SOHCAHTOA, would be opposite over hypotenuse. So 1 over 2. Opposite over hypotenuse. Let's do the cosine of 30. So the cosine's adjacent over hypotenuse. So square root of 3 over 2. Tangent of 30 would be opposite over adjacent. So 1 over root 3. Now we got to rationalize that. Can't have that square root on the bottom. So we end up with square root of 3 over 3. Square root of 3 times square root of 3 is 9, or 3. Now, what about if we're doing it from the 60 degree as our reference angle? So let me rewrite this. 30, 60, 90, 1, 2, root 3. But this time, 60 degrees our reference angle. So if you notice, opposite 60 degrees is at root 3. So here's the opposite side, right? That's the opposite side. This would now be the adjacent side if I'm looking at the 60 degree. And of course, the hypotenuse is always opposite the 90. So let's do sine of 60 degrees. Sine is opposite over hypotenuse. So sine of 60 degrees would be root 3 over 2. Cosine of 60 degrees would be adjacent over hypotenuse. So 1/2. Tangent of 60 degrees would be opposite over adjacent. So root 3 over 1. All right, with that information, you guys, we're going to see how this right triangle trig plays into this first quadrant for the unit circle. Okay, so we have, let me take the 30, 60, 90 for a minute. So here's our 30 degree, 60 degree, 90, 1, 2, root 3. Okay. Now what I'm going to do is, by similar triangles, I'm going to build, and I'm going, can you see how, like, if I rotate 30 degrees in the unit circle, see how I have a 30, 60, and I drop that straight down, 30, 60, 90. Can you see that? Now, the radius, though, of this is, in other words, the hypotenuse, my radius is 1, right? So this is half the size. So by similar triangles, right, if my radius is 1, but I still have a 30, 60, 90, right? So 2 is to 1 as 1 is to, what would this be? Well, that'd be a half, right? I'd cut that in half. And what would the square root of 3 be? It'd be half of it, because it's been cut in half, right? See how it's a 2 to 1 ratio? Or if you want to think about it, or a 1 to 2 ratio, if you will. Small to big. Okay, so let me write that in over here. So this is a distance of root 3 over 2. This is up a half. Now, if you notice, the cosine at 30 degrees, the cosine, which is the x value right there, is adjacent over hypotenuse. So the cosine of 30 degrees, see how it's adjacent over hypotenuse? Root 3 over 2. And then notice the sine of 30 degrees. The sine of 30 degrees, which is opposite over hypotenuse, 1/2 over 1. See how that 30, 60, 90 informs that? And then for a 45, 45, 90, right? And you could fill out this whole table from those special triangles. All right? So you could build this with right triangles, if you will. You build this unit circle. I'm going to go ahead and erase this. And I just want you to remember that's the cosine of 30 degrees right there. That's our x value. That right there is our sine 30 degrees of y value, right? You could build that. And then using symmetry, we have this whole first quadrant filled out, right, with symmetry. And then we could keep going over here, here, and here. So we go, and notice, let me go with this one. This is also a 30, 60, 90 triangle. The only difference is it goes to this point right here. So it's, even though this is a distance of √3/2, it's on the unit circle. So your x value is negative, your y value is positive. All right, so this one, these correlate. See how they go straight across, except your x is negative, your y is positive. And then this 45 correlates over to there. And you can, so that'll be negative √2/2, positive √2/2, and so on. This one correlates with that one. Negative x, positive y. And so with symmetry, you can build your entire unit circle. And so here's your unit circle. Again, notice how they correlate over, right? Because of symmetry. And then, do you see how those correlate there? And these correlate here. And so on. So now that we have this unit circle referenced here, okay, we're going to evaluate the 6 trig functions. So let's say our t is 2 pi thirds. In other words, we rotate 2 pi thirds, because remember, on the unit circle with a radius of 1, when I go 2 pi thirds, or 120 degrees, right, I'm rotating t amount. It's the same as t. This t right here, that t is the same as my theta being 2 pi thirds. So it's a rotation around. And I end up right there. Okay? So then I could say, oh, okay, cosine of t, or cosine of 2 pi thirds, if I rotate 2 pi thirds, cosine is my x value. And my x value is -1/2, as you can see. There's my x. The sine of 2 pi thirds is the y value. The y value there. So √3/2. Okay. Who flips over the sine? Sine is flipped over the cosecant. So the cosecant's 1 over the sine. So that'll flip it 2 over √3. But I got to rationalize that. So 2 √3/3. The secant's the reciprocal of the cosine. So that's 1 over the cosine. So flip that -1/2 over. That's -2/1. It's -2. The tangent. Remember, the tangent's the sine. The tangent of 2 pi thirds is the sine over the cosine. Well, our sine was √3/2, and our cosine was -1/2. So I just got to simplify that. So multiply by the reciprocal, 2/1 to simplify that. And so it looks like I've got -2 √3/2, or -√3. That's our tangent. Cotangent would flip that around. So it's 1 over the tangent. Or you could do cosine over sine. Or cosine over sine. Either one of those. But let's go ahead and just go 1 over tangent. Let me take that negative up top. And then let me rationalize that. So we got -√3/3. And there's our cotangent. You know what? Let's do another one. Let's do another one before I move on here. Instead of 2 pi thirds, let me erase all these. Let's go with Let's go with, how about, let's go 5 pi force. 5 pi force, right? So we're rotating 225 degrees, right? And if you're not sure, of course, multiply by 180 over pi, and you'll see that it's 225 degrees, right? That's how you get to 225 degrees. So, okay, so we're going to rotate 5 pi force 225 degrees. So I'm starting right here. Let's draw this. And I'm going to rotate clear around to 225 degrees right there. Okay, so 5 pi force. In other words, my arc length is 5 pi force. Okay, so 5 pi force correlates or projects onto that point. So that's my point of interest, right? That's my x and y that I'm looking at. So let's start with the sine. So the sine, let's go the sine of 5 pi force would be the y value, negative root 2 over 2. The cosine would be the x value, negative root 2 over 2. The tangent will be sine over cosine, which in this case is 1, right? It's the same thing, negative root 2 over 2 over negative root 2 over 2. Who's the reciprocal of the sine? Cosecant. So the cosecant flips that. So instead of negative root 2 over 2, it'll be 2 over negative root 2. 2 over negative root 2. And then I'm going to go ahead and, here, let me get a little room here. Let me rationalize that. And let me take the negative up top. So I got negative 2 root 2 all over 2. Notice the 2's cancel. So negative root 2 is the cosecant. The reciprocal of the cosine is the secant. So instead of negative root 2 over 2, it'll be 2 over negative root 2. And it's the same process, right? Notice it still ends up being negative root 2. And then finally the cotangent will flip. Would be the cosine. Would be the cosine over the sine. So 1. All right, so let's keep going here. We got if f of theta equals sine of theta, g of theta is cosine of theta. What would g of theta be if theta is 45? So we're just using the g function. So g of theta is cosine of theta. Well, if theta is 45, then let's throw the 45 degrees in. So we're just finding the cosine of 45 degrees. So don't use a calculator. This is saying, hey, do it with the unit circle. So what would the cosine of 45 degrees be? Is that the x or the y? Well, if you remember, the cosine is the x. So I'm looking on my unit circle right here. I'm rotating 45 degrees. I get that mark right there. I'm looking on my unit circle. And it's the cosine right there. Root 2 over 2. All right. Let's do this next one here. F of theta is sine of theta. G of theta is cosine. Find the exact value of negative. So negative's in front. F of theta over 5. And notice theta is 150 degrees. So let's do that. Let's throw in the 150 degrees. So 150 divided by 5, I got 30 degrees. Negative f of 30. Now remember, f of 30, f of sine theta. So this is negative sine 30 degrees, right? Here's the f of 30 in parentheses, sine of 30 degrees. So now I'm looking on my unit circle. I rotate 30 degrees, and I get this point on my unit circle. Sine of 30 degrees is what? the y value. So the negative stays in front because it's negative f of 30 degrees. Negative sine of 30 degrees is the y value. So this just ends up being negative a half. Okay. Now, like I say, on the first test, and by the way, that's it for today's lecture on 6.2, but I wanted to just talk about what I would do where you do not have the unit circle on the first test. So how do you build this first? So it goes 30, right? That's a 30 spot is that first one. And then you've got so this is at 30 degrees, this is at 45 degrees, this is at 60 degrees. Of course, this is at 0 degrees. Let's do their accompanying at 90 degrees. Sorry. So, and I've got the points 1, 0. This is on the unit circle. 0, 1. Negative 1, 0. 0, negative 1. At least this is how I like to build this. Okay. And then if you can remember your 30, 60, 90s, triangles, 1, 2, root 3, sine of 30 degrees is opposite over hypotenuse. That's the y value. Cosine of 30 degrees would be adjacent over hypotenuse, root 3 over 2. Okay, and then for the 45, 45, 90, 1, 1, root 2. Sine of 45, that's the y value. Sine of 45 would be opposite over hypotenuse. Well, 1 over root 2 rationalized is root 2 over 2. Or you can just memorize the points too. But this is how you build it if you know your 45, 45, 90s. Adjacent cosine is adjacent over hypotenuse. Well, 1 over root 2 is again rationalized to be root 2 over 2. Now for the 60, 30, 60, 90. Now I'm looking at the 60 degree as my reference. Sine of 60 is opposite over hypotenuse. So that's the y value there. Cosine of 60 would be adjacent. There's adjacent next to the 60 over hypotenuse, 1/2, right? But notice these 2 points just flip-flop, the 30 and the 60. You know, the 30 has a root 3 over 2, and the 1/2 is the y, but they flip-flop on the 60. Okay. Well, once you have your first quadrant, and I know I haven't filled in the radians yet. I will in just a second. But you can finish out the rest of this because this just goes 90 plus 30, so 120 degrees. And then 90 plus 45 is 135 degrees. And then 90 plus 60 is 150 degrees. And of course, halfway around a circle is 180. And then we'll go 180 plus 30, 210. 180 plus 45, 225. 180 plus 60, 240. 180 plus 90, of course, 270 degrees. Now I'm going to go 30 degrees from there, 45 degrees from there, and 60 degrees from there. So 270 plus 30, 300 degrees. 270 plus 45, 315 degrees. 270 plus 60, 330 degrees. And then I'm looking at, I'm like, oh, these just correlate over. You know, that one correlates with that one. So I have a negative x, positive y. The 45 correlates with the 135. So again, it's just 45, 45 there. But it's a negative x, positive y, because it's on that unit circle. And then that one correlates to that one. So you got negative 1/2 positive root 3 over 2. And then these will correlate. I like to have them correlate right there. So I got negative root 3 over 2, negative a half, negative root 2 over 2, negative root 2 over 2, negative a half, negative root 3 over 2. And then you could go here, or you could bring them over from quadrant 3, whichever you prefer there. Root 3 over 2, put a negative a half, positive x, negative y, positive x, negative y, positive x, negative y. Now I've filled everything out except for, oops, erase these lines here. I don't have my radians on here. All right, so you just got to now convert everything to radians. So like if I'm going from degrees to radians, remember from last time we would take the degree and we multiply by, because this is pi radians over 180 degrees, and this gives you 1/6, so that's pi 6. So 30 degrees is pi 6 radians. 0 degrees, of course, is 0 radians. Now I do the next one. 45 degrees times pi over 180 degrees. That's 1/4. So pi 4 is 45 degrees. Now I go to the next one. 60 degrees times pi over 180 degrees. And that's pi thirds. Pi thirds. Same thing for the 90 degrees. Multiply by pi over 180 degrees, and you get 1/2, so 1 pi over 2, and you keep doing that for all these. So 120 degrees times pi over 180, that'll give you the 2 pi thirds. 135 times pi over 180, that'll give you the 3 pi fourths. And 50, that'd be the 5 pi 6. Halfway around is pi. 180 degrees times pi over 180, of course, is pi. 210 times pi over 180, so that'll give you 7 pi 6. This one will give you the 5 pi fourths. 240 degrees times pi over 180 give you 4 pi thirds. 270 degrees is 3 pi over 2. 300 degrees is 5 pi thirds. Well, I'm running out of room here. 5 pi thirds. That one will be 7 pi fourths. And finally 11 pi 6. And now I've filled out, that's how I like to fill out a unit circle, so you can have that referenced when you take exam 1 without it. Okay? Thanks so much for watching. We'll see you guys next time.